Good morning, my dear students. In this particular video presentation again, we'll discuss some more problems meant for competitive examinations or JEE. I'm taking problems from almost different topics. Each will be definitely very useful to you. Just concentrate on how it is being done and you'll be able to apply your mind when you come across such problems in your examinations. Before going to the problem on probability today, I'd like to discuss one particular example. Okay, find the different permutations of the letters A comma A comma B comma B. It is two A's are alike, they look alike. Okay, they look same, they are similar. Two B's are similar. Okay, let me just think about the various arrangements. I'll make the arrangements using the positions of the two A's. A's can be in first and second position, A in first and third position, A in first and fourth position, A in second and third position, A in second and third position. Okay, just see here, second and third position, and A in second and fourth position, and finally A in the third and fourth position. Only these are the different possibilities. I'll just explain once again if you want. Okay, looking at the positions of two A's, I'll be able to explain this properly. A in the first and second position, first and third position, first and fourth, second and third, second and fourth, third and fourth. These are the arrangements. These are the possible arrangements. I can't go beyond these arrangements. Listen carefully. By differentiating this A's as A1, A2, see here, I'll be able to have A1, A2, BB and A2, ABB. I'll be having two different permutations. Now from 1, 2, 3, 4, 5, 6, there are 12 different permutations finally. Again, differentiating the two B's as B1, B2, I end up with A1, A2, B1, B2 and A1, A2, B2, B1. I'll have two different permutations. Therefore, 12 into 2, there are 24 different permutations. Practically speaking, if all four letters are distinct, the number of different permutations is as equal as 4 factorial, which is 24. Therefore, number of different permutations of two A's and two B's which are alike can be written as 24 by 2 into 2. 24 by 2 gives you this 12. 12 by 2 will give you 6. This is as equal as 4 factorial by 2 factorial into 2 factorial. Practically speaking, the 4 factorial here is total number of letters. The 2 factorial here is how many letters are repeated here. So repeated or so many letters are alike. And I repeat once again, there are two A's and two B's. I'm trying to find out how many arrangements are possible where the two A's are looking alike and two B's are looking alike. Looking at the positions of two A's, I'll be able to think of the various arrangements. First and second position, A occupies. First and third position, first and fourth position. The ascending order I'm writing. Second and third, second and fourth, third and fourth. Easy to remember. Replacing the two A's by A1, A2, differentiating them, I'll be having two distinct permutations. For 6 into 2, there are 12 distinct permutations here. Again, replacing these two B's by differentiating them, writing it as B1, B2, I'll get two distinct permutations each of them. Therefore, 12 into 2, therefore 24 different permutations there. All the four letters are distinct or different, whatever it may be. Therefore, number of different permutations, two A's and two B's which are alike. Two A's are alike, two B's are alike. If you want, you can write individually. Is given by 24 by 2 into 2. This 24 is nothing but 4 factorial. Is total number of letters being used divided by 2 factorial, which is nothing but the one which are alike. into 2 factorial which are alike. If 3 are alike, I'll have 3 factorial. Therefore, I'll have a generalization now. I'll give you the generalization. If there are n elements, in which P1 are alike, P2 are alike, etc., Pn are alike. If there are n elements in which P1 are alike, okay, P2 are alike, etc., etc., Pn are alike, P1 are alike, P1 are alike, P2 are alike, etc., Pn are alike. They are similar. Okay, the number of such permutations, number of distinct permutations here would be n factorial by P1 factorial into P2 factorial into P3 factorial, etc., Pn factorial. Important thing here is with P1 plus P2, etc., Pn happens to be n. Sum of those numbers should be is equal to n. I repeat, if there are n elements in which P1 are alike, P2 are alike, Pn are alike, with P1 plus P2, etc., Pn is n. Sum of those numbers equal to total number of elements n. The number of distinct permutations there would be n factorial by P1 factorial into P2 factorial, P3 factorial, etc., Pn factorial. Instead of n, I have 4 here. Instead of P1, P2, I have 2 here. 2 plus 2 is 4. Remember this carefully. It's not a difficult task. Remember the rule. This is the formula to be remembered to apply in your problems further. Okay. I will just take a particular case. Find the distinct permutations of the letters of the word approximation. Okay, find the probability. I'll think about the probability. Find the probability of arrangement of the letters of the word approximation in which two A's are alike. So, it starts with A and ends with A. Sorry. Okay, I just repeat the question. You are given the word approximation. Find the probability of arrangement of the letters of the word approximation which starts with A and ends with A. Okay, I just see the word. I am talking about the answer now. I repeat the question once again. Find the probability of arrangement of the letters of the word approximation which starts with A and ends with A. Okay, the word approximation has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 13 letters. Namely, what are they? 2 A's, 2 P's, 1 R, 2 O's, 1 X, 2 I's, 1 M, 1 T, 1 N. You can just check 2, 4, 5, 7, 8, 10, 13. It's correct. Now for total number of arrangements here would be is equivalent to your n of s. 13 factorial by 2 factorial into 2 factorial into 2 factorial into 2 factorial, by which rule which we have derived just now. Okay, 13 factorial by the repetition, the factorials I should do. In fact, I should write 1 factorial also. 1 factorial is anyway 1. I need not write it down anyway. If the arrangement starts with A, comma, ends with A, the number of such arrangements other than these two, I have 11 letters. 11 factorial by 2 factorial into 2 factorial, 2 factorial. It means I'll make the remaining arrangements with the remaining 11 letters. There are 2 P's and 2 O's and 2 I's. Only 3 letters are repeated twice. And after every other arrangement, I'll put A at the beginning, the second A at the end. That is the real meaning of this kind of arrangement. I'm eliminating 2 A's means after arranging the remaining letters, I'll insert 1 A at the beginning and 1 A at the end. That is the meaning. Therefore, this is my n of A. Therefore, required if I consider this as event A, this is my n of A. Required probability is equal to 11 factorial by 2 factorial into 2 factorial into 2 factorial divided by 13 factorial by 2 factorial into 2 factorial into 2 factorial into 2 factorial. Here 3 2 factorials will get cancelled. 11 factorial into 2 by 13 into 12 into 11 factorial. This will anyway get cancelled. I'll end up with 1 upon 78. 1 upon 78 is the answer. 1 upon 78 is the answer. I repeat the whole process. The word approximation has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 13 letters, namely 2 A's, 2 P's, 1 R, 2 O's, 1 X, 2 I's, 1 M, 1 T, 1 N. You can check 2, 4, 5, 7, 8, 10, 13. It's correct. Total number of arrangements as equal as n of A's. Number of elements in the sample space. 13 factorial by, write the product of factorial where you have the repetitions or the letters are repeated. If the arrangement starts with A and ends with A, number of such arrangements, other than those two A's, I have 11 letters in which P's are repeated twice, O is repeated twice, I is repeated twice. Now this is my n of A if I take this as event A. Now for required probability here is n of A by n of A's. Here 2, 1, 2 goes up, 11 factorial 2 by, apply n factorial is n into n minus n factorial twice, 13 into 12 into 11 factorial. 11 factorial gets cancelled, 2 6 are 12, 6 13s are 78. 1 by 78 is the answer. 1 by 78 is the answer. I'll just add up one more problem. If the letters P, N occupy end places, end places, one at one end, P starting with P, ending with N, or starting with N, ending with P. That is the meaning. If the letters, arrangement has end of the letters as P and N occupying the end places, starting with P, ending with N, or starting with N, ending with P. That is the meaning. Find the probability of such an arrangement. Okay, then total arrangement we have just seen. Okay, I mean to say 13 factorial by, I am not repeating, it is just done for you. Okay, now it already starts, I mean to say it, I have to start with P and N with N, or start with N and N with P. That is the meaning. Now for other than P and N, the number of arrangements will be 11 factorial by 2 factorial into 2 factorial into 2 factorial. There are 2 A's and 2 O's and 2 I's that you can anyway check. Okay, therefore the factorial should be carried over. And the P and N can be interchanged in two ways. P and N can be interchanged in two ways. I repeat, other than P and N, actually the arrangement has to have the n points, n positions as P and N occupying each in one of the places. That's the meaning. It means I have to start with P, ends with N, or it starts with N and ends with P. That's the meaning. Therefore, other than P and N, the number of arrangements will be this much. The P and N positions can be interchanged in two ways. Therefore, required probability here will be 11 factorial into 2 by 2 factorial into 2 factorial into 2 factorial divided by 13 factorial by 2 factorial into 2 factorial into 2 factorial into 2 factorial. This 2 factorials will get cancelled. This 2 goes up, 13 into 12 into 11 factorial. This will get cancelled. Here this is 6, this is anyway 3, this is reduced to 1 upon 39. Answer is 1 by 39. I repeat, other than P and N, there are 11 letters. They are arranged in 11 factorial by 2 factorial, 2 factorial. There is a repetition of 2 A's, 2 O's and 2 I's. I rubbed off the number of letters anyway. Go back and check. And P, N can be interchanged. The positions can be interchanged. It starts with P, ends with N, or it starts with N, ends with P. You can have. For required probability is this much by this much. Here 2 factorial, 2 factorial, 2 factorial gets cancelled. This 2 goes up. 11 factorial, 2 into 2 by 13, 12 into 11 factorial. 2 6 are 12, 2 3s are 6. 3 13s are 39. 1 by 39 is the final answer. Anyway, I'll check for the calculations as usual and then I'll upload. Thank you students for patient watching.